tonight I remembered to stream to Hack Update's account and not my own. Give everyone a minute to get in and then we will get started. We're so excited. I was ready like 5 minutes before class today, and then I looked up at the time and it was 5:30. It's like, whoa, where did those 5 minutes go? Very common experience when writing code, except it's not 5 minutes, it's 5 hours. And then you realize you haven't eaten or gotten up or just been so invested in your code that you forgot what time was. It's both an awesome feeling and a very terrifying feeling at the same time. All right, let's kick it off. I think you all know what is coming. What did we do yesterday? Would help if I would open the chat. Yep, Brandy, we started SQL. SQL stands for Structured Query Language. It is the way we interface with most databases, at least most relational databases. Kyle, to your point, relational databases meaning that we can tie two pieces of data together across tables. I don't think we got into that much last night, but we will definitely be seeing more of that tonight. And then we will be putting that in practice probably starting early next week. Definitely when we start talking about database modeling and how we structure our data and tables and all of that stuff. But I am saving most of that for next week because tomorrow I would like to get into kind of how to use databases practically, how to integrate it into our backend. We are going to actually redo our messages app twice. The first time we do it, we are going to use just raw SQL. We're going to get Postgres set up tomorrow, which is going to be a bundle of fun because installing servers is always interesting. But we're going to get our database server set up tomorrow, get our node backend connected to it. And then we are going to switch over to using what we call an object relational mapper. We're going to use a package called Sequelize, and we're going to see how much better it is. And then you guys can all find things to throw at me when you say, why did we learn SQL in the first place? This is so much easier. And the reasoning behind that is because it is important to know how to query a database outside of just your code and be able to maintain that and run select statements and read other people's SQL and all of that kind of stuff. Yes. So other things we covered yesterday, things that stuck out to you, light bulb moments that you had, anything like that. How about get ignore? What did we do with get ignore? What was the point of get ignore?
To ignore all the files that you push and pull.
Exactly, yeah. Just to ignore the files out of our Git repository. So we're basically just telling Git to ignore them. So yeah, you got it, Shahil, exactly. Tobelia, I'm glad you're liking Khan Academy. Carolyn, I believe all the issues have been resolved in Khan Academy. It's just the first exercise may not be marked as complete on my side. But I'm going to just assume that everyone got the first one done because it's kind of hard to do any of the other ones unless you have the understanding of the first one. So shout out to Ariel, who I believe is not in class tonight, and for good reason. She was the only one who made it all the way through all the exercises and got everything complete. So I was not expecting you guys to be able to do that, but when you find something you like and is fun to do, it makes sense to power through it. So we are going back to Khan Academy tonight. I'm going to stick to my guns. The feedback from last night was either that it was right on pacing wise or leaning on the too slow side. So I'm going to do one more night of Khan Academy because that's all it takes to get through their content. And then once we get through that, we will be back to my normal breakneck pace in coding and having me teaching and going through the code and all of that stuff tomorrow. But we've got one more day of Khan Academy, so hopefully the pacing won't drive you too crazy. With that said, two things to address. One, I'm going to drop the link for office hours in Slack. Do not worry about exercise 1 not saving. I'm just going to assume that everyone got that done. So you do not have to worry about the first one not saving or not saying complete. You can just move on to the next ones. I am grabbing the link for office hours and putting that in chat. You guys could vote on that. We can lock in at the end of class tonight what time office hours will be Friday, Saturday, or Sunday, whatever time works best for you or gets the most votes, I will roll with. And then I am also going to kick off a second poll in Zoom just to give you guys an option. So we can either play through all the videos, have me do my little explanation at the end of them, and then break at the end of class for any questions or talking through the exercises. So basically saving all the exercises for the second half of class. Or we can, Shahir, what do you mean by it all says Thursday?
The poll just says Thursday. Like there's like 3 Thursdays or whatever.
Are other people seeing that as well?
Oh, it looks like you put it in a comment to, it like ended up in a comment to Annalina's.
Oh, sorry, I may have sent the wrong link.
Wait. Yeah, I don't see it. Actually, I don't see it at all.
No, I pasted the right link. When I open it, it takes me to the simple poll. The other way to get to it is if you just go to the CIC Student C2 channel in Slack.
Oh.
I copied and pasted what was in the Slack, but it doesn't show up because I'm guessing the semicolons in between is like emojis.
Yeah, so that's for the Annalina poll.
Yeah,
but if you scroll up to yesterday at 12:24, I sent another poll for office hours in there. The link may not have scrolled you to the right section. So if you just scroll up to yesterday at 12:24, you should see the poll for office hours, and hopefully you can vote in there for those. Thank you, guys. Yeah, it looks like it's working now. Thank you, Jahil, for that feedback. Okay, so for class tonight, The options are either play through all the videos, skip over the exercises, and do all the exercises at the end that you guys can work on, and I can answer any questions. Or we can do the approach that we took last night, which was play the video, have me talk through it a little bit, give you guys a break to work on the exercise, and then when the majority of you guys have it done, we can move on to the next one. So really up to you. I'm fine doing it either way, but I'm going to launch that poll in Zoom, and you guys can vote whether or not you want to do all the videos and then do all the exercises at the end, which is the first option, or take a break after each video and talk through it. I swear to God, if this is another tie vote, I may kill each and every one of you. And right when one takes the lead and you think, oh, good, it's not going to be tie, more people vote, and it goes back to being tied. One of you did not vote. So, Caitlin, I'm going to make you the tie-breaking vote.
Okay. Oh man, now they're gonna know what I voted now. Wait, can I even vote? I'll just tell you. I say take a break after each video.
Okay. So we will do that. Just to prove that it was tied, I can actually share it with you guys and show it was actually a tie vote. All right. So before we jump into that, any questions from yesterday that are not related to the assignments? Because let me put it like this. If you have questions on any of the assignments that you kind of worked ahead on, you'll have the opportunity to ask those questions as we go through it. If you were stuck on any of the assignments, I think it was the first 4 of them from yesterday, feel free to ask those questions now. Any questions in general about relational databases or SQL, or whether there's stuff coming up that we're covering, or things you may have seen in the news, or anything at all. The SQL homework assignments, by the way, are not due until Sunday at 11:59, just like the way we do in Google Classroom. So you don't have to have them done, by tonight. But I will be checking back in on Khan and then giving everyone credit for that over in Google Classroom Monday or Tuesday. Class is canceled next Monday for the 4th of July weekend. I'm aware that the 5th is actually a Monday, but the 5th is the federal holiday. And so we will have a night off of class next week. And in addition to the office hours poll, Annalena did post a poll for what date works best for you guys. I did post a comment in there saying that I think the first date would probably work the best, only because I'd rather give up a week of full stack because I've had 5 weeks to cover it, and not take a day from Nathan's week when he's going to be doing DevOps and testing, which are 2 very important things that you could definitely be tested on during a job interview. So just because I've had that big bulk of time, I would rather not steal more time from Nathan. But if any of those dates work better for you guys, definitely vote in Annalena's poll. That should be towards the bottom of the CIC Student C2 channel. And Friday at 7:30 right now has the lead for office hours, but it is only in the lead by 1. Saturday at 11 a.m. is right behind it. So I will allow you guys to vote until the end of class tonight and then make the call for office hours then. Okay. One final reminder, the first assignment, don't worry about it showing up as complete in Khan Academy. Otherwise, they should, the rest of them should all have no trouble marking them as complete. Okay, I am going to fire up Khan Academy and we can get to work. Sorry, I don't know if I shared audio on that. I did not. Let me try that again. Okay, take 2.
I've spent the last few talkthroughs making a grocery list. Well, now that I've realized how much eating I do, I realize what else I should be tracking in a database. How much exercise I'm doing. So I'll start by pasting in some statements that create a table and insert a few rows of data. Let's see what I have in exercise logs. We have an ID, of course, a type, which is a string like biking or dancing, minutes for how many I spent, calories for how many I burned, and heart rate for how high it went. Now I'm inserting the data using a slightly different syntax than before. Notice how I'm specifying the column names in parentheses after the table name. When I do that, it means that I don't have to specify every column value here. I only have to specify the ones that I give in this list of column names. Now, do you see which one I didn't specify here? The missing column is ID, and that's very much on purpose. ID, here we go. The ID column is the primary key in the table, and it's set to auto increment. That means that the database will automatically fill it in for us when we tell it to, by picking an ID that's different from the other rows in the table, usually a number that's 1 bigger than the biggest number so far. Now, I would rather have the database figure that out than have me figure it out. So I usually like to do my inserts this way, leave out the ID, let the database do that work for me. Okay, so there we go. My database table is set up, and it looks like I've even done a bit of exercise. Go me! Let's find out where I'm burning the most calories with a simple query. I'll just modify this one. So select from exercise logs where calories greater than 50, and we'll just order by calories as well. Okay, so I've done 2 activities where I've burned more than 50 calories, and it looks like dancing burned the most. Now, I want to find out which activities I've done that have burned more than 50 calories, but also taken less than 30 minutes, because I want to exercise more efficiently in the future. It's pretty obvious from looking at the current results. There's only 2 results. It's easy to look at that. But just imagine that there are thousands of rows. Maybe this is data from thousands of users. I would need a way to filter that down in the SQL query itself. To do that, I can use the AND operator to combine those multiple conditions, like to only return the rows where calories are greater than 50 and minutes are less than 30. Haha. So now I only see one result, dancing, which means I should just spend my whole life dancing, which sounds pretty good to me. Okay, so in a similar way, I could use the OR operator to return rows that meet any of some conditions. Like, let's say rows where calories are greater than 50 or heart rate is above 100. And that helps me find the most vigorous exercises. Now we can see that dancing and biking are both good, and actually I do like biking. It's just a bit harder. Now you can have as many OR and AND operators in your query as you'd like. The AND operator has precedence over the OR if you've got both of them in the same query, but you can always use parentheses to change the order of evaluation, just like with math expressions. Now I want you to try these out in the next challenge and stay tuned for the next talk through where I'm going to show how to do some interesting things using this type column here. See you then.
Actually, before we move on to the challenge, I'm going to talk through. No, stop it. I'm going to talk through this a little bit. Okay, so can I make that go away? Yes, I can. Okay. So what we did here, we want to get practice with our create table. So we're going to be doing that in a lot of these exercises because you will be creating a lot of tables using SQL. So we issue our command, our create table command. Hopefully these keywords in SQL are starting to sink in a little bit more. We give it our table name, and then we use ID integer primary key auto increment. Okay, lots of words in there. It is typical for almost every table to use an ID. Without an ID, we can't tie data together relationally. We can't just be like that row over there. We almost always use IDs to tie tables together for our relations. And we'll be seeing that coming up soon with a join query in SQL. So we always have to specify a data type. IDs are almost always integers, especially in SQL land. And then we say primary key. This is helping the database know, hey, this is a special field, and we will probably be using this down the road to link tables together. And then we have our auto increment. And this is the new one that is basically saying whenever we do an insert, just add 1 to whatever the ID was before it. So we don't have to worry about specifying that. Now we come down here and we do our insert into, and we always specify a table name. But this is the more typical way of how we would do an insert into, because it turns out when you have a lot of columns, we only have, 5 here. But when we have a lot of columns, it's easy to get lost in what values am I putting into what columns. So it just so happens that the order of these columns is matching the order up here, but it doesn't have to. So if we wanted to, for whatever reason we wanted to put heart rate as the first one, we could do that here as long as we took our value and made sure that that heart rate was lining up with our insert, right? And so whatever the order is in our insert into for our columns here is going to be where the data gets inserted here, just matching and lining all of that up. And then so we just practice a little bit more with our where queries. We can use the and command. Some databases will actually let you do a double ampersand. Let's see if it will let me do that. Does look like that still works. But it is more common in SQL land to use the word and written out or the word or written out. And then we've got our select down at the bottom. Any questions on that before I break out into the exercise? Yep, you got it, Shahil. Okay. So point of this exercise is we still want to create our table. We're inserting our table, but we are just going, we're going to start by selecting the titles that are in there and then starting to layer in our select queries, our select queries and our where queries to get the right data out. So I'm going to stop my share. I'm going to kick off a poll, and I'm going to give everyone a chance to complete it. And then once you get it done, oh, I have to stop sharing. I will go over the solution with you guys. gonna lower my normal vote threshold count to like 6 or 7 people who say they're done or are ready to move on tonight. And we're at 5 right now. So give you guys another minute or two, and then I'll talk through the solution.
Excuse me, Max.
Yes.
It's Carolyn. Oh, I guess my video's not on. Sorry.
All good.
I'm displaying all the titles of the songs.
Yep.
Which is the first step. And it's still on step 1 of 3 and everything is grayed out. I can't click on next step. And I didn't notice, let me double check up top. Yeah, they didn't change the instructions. So
Do you
I
want
don't
to share
know
your
if-
screen?
yeah, sure.
So what does it say in orange?
Well, what I did was before I typed select in on the left, I just clicked on the table name.
Yep. So if you scroll down to where your select is.
And then they had 2 of these.
Yep. So you
Okay.
added that select star from songs. If you take out that select star from songs and select only the title,
That
it
did
should
that
let you progress.
when I clicked on the table, yeah, and it put 2 of them in because I think I must have clicked twice. Oh, okay. This isn't like Code Academy where they wrote code camp where they put. Okay. So I should now be able to move on. All right, great. Thank you.
No problem.
Stupid question. Where's the screen sharing? Stop.
Okay, so we got 7 people in saying they've got it done or are ready to move on. So I'm going to do that. So let me just quickly talk through how I did this. First, they wanted me just to select the title from the songs. So I added in my select statement. The table name almost always comes very early on in the statement. I'm sorry, the column name, and then from, and then the table name. So then we got a little fancier and we said select title from songs. One thing you may notice is that I have from in lowercase here and where in uppercase. SQL is not particularly particular about case, especially in the keywords that we're using in SQL. So capitalizing this to all caps is completely fine. Whatever makes more sense to you is fine to use. And so we just did our where, and then we do our column name equal to, and then we want to put this in quotes, right? Because we're looking at the value of what is in the column. And then we are going to say, or greater than 1990. And then we don't put 1990 in quotes because just like JavaScript, it's a number, not a string. And then finally, we did a little select where the mood was still epic and the release date was after 1990 and the duration. And then I got fancy here because that's where they wanted to catch you. The duration was measured in seconds. And so they said 4 minutes. So I could have done 4 times 60 and typed that in here. Or you can use a little math in your SQL query and make it do that calculation for you. Any questions on that? Okie doke. Moving on. And oh no, I'm sharing my sound this time.
I'm back with my table of exercise logs, and I've added a few more rows. Now, if I wanted to filter these logs to just show my biking logs, I could just add where type equals biking. Simple. It's getting sunny outside, so actually what I want to find is all of the outdoor activities, not just biking. So to do that, I can use the OR operator that we just learned, checking each of the different outdoor types. So type equals hiking, or type equals tree climbing, or type equals rowing. Unfortunately, I don't yet have a mountain or a tree or a lake in my home, so all of these are outdoor activities. All right, so that worked, but there is actually a simpler way to do this query, and that's using the in operator. The in operator will check to see if a particular value is in a list of values. Let me show you. So we'll take this query and I'll paste it, and then I'm going to replace this equal sign with in, and then put a parentheses, and then I'm just going to separate each of these strings with a comma instead of that whole long or type equals blah. Ta-da! Same results like we expected, but this query is easier to read and it's a bit shorter too. We could easily also do the inverse query if we just want to see the indoor activities. We just write not in. Ha. So that's just dancing, and I'll save that for the winter time. Let's change it back to in and our outdoor activities. And I'm going to show you something a little more interesting that we can do with in. First, I'm going to need another table of doctor recommended activities. I'll paste in the SQL for that. Let's see, where do we have it? Here. So here we've created a table of doctor recommended activities, which just has a type, which matches our type from up here, and a reason, which is why the doctor recommended it. Now, what if I wanted to see all my exercise logs that correspond to doctor recommended activities? Well, first, I might want to see what are those doctor recommended activities. So select type from doctor's favorites. Okay, biking and hiking. So I could just take this query and modify it and just shorten it to biking and hiking. However, if the doctor's favorite tables changed, like there was a new row added or a row deleted, then this query would be out of date. What I want is for this query to always be up to date with what's in this table here. So what I can do is use the in operator directly with the results of a SQL query, a select query. And it's actually very simple to do. I'll replace what's in the parentheses with the query that we did before. Ta-ta! Cool. So we call this inner query a subquery. It's the query that we're doing inside the outer query. And now this query will always pull based on whatever's in the doctor's table at the time. It will stay up to date. And this is a pretty simple subquery, but it could actually get really complex. It could be as complex as any of the queries that we've learned so far. Let me show you an example. What if we only want to select the favorites that the doctor recommended for cardiovascular reasons? So we could say where reason equals, and then we could paste this whole long reason in here, and we see hiking. But what if for some reason we didn't have the period in here? Well, now we actually see nothing for that query because it's trying to do an exact match and it can't exactly match that. So there are times like this when we want to do an inexact match, and we can do that with the like operator, which is a pretty neat operator. And so to do it, we're just going to take this and I'm going to replace the equal sign with like and get rid of, because all we care about is that very important word cardiovascular. That is what we're looking for. So we say cardiovascular, and we also put a percentage sign on either side, which acts as a wildcard. So this should match any rows which contains the word cardiovascular anywhere, and it did. Yay! Okay, so that's pretty cool. Whew. We covered a lot in subqueries like. Hopefully you're pumped to try them out in the next challenge, or take a break, go climb a tree, and come back. Either way, I hope you have fun with it.
Okay, so hopefully pretty self-explanatory. We can use our in statement and just list out a list of values, and that is kind of like how you can think of that as using it as an array. We can get fancy and use a select query to figure out where our queries are coming from another table, or we can even get fancy and use this wildcard. So the wildcard that we used yesterday in the get ignore was an asterisk or a star. That is more common, but in SQL land, for whatever reason, we use a percentage. So the reason why we put a percentage at the beginning and at the end is we basically want to say that there can be text that comes before this or text that comes after this. So if you wanted to say, oh, the text needs to end in cardiovascular, we would put our percent at the beginning saying there can be text that comes before this. But if we didn't put the percent at the end, that would basically be saying that the whatever column that we are looking in, the reason here, it needs to end with the word cardiovascular. So 3 different kinds of select queries here. We start using in. We can do our in. I don't think we can do our in example here where we just provide a list and we don't have to use a subquery. We can come down and we can use an in operator where we just pull it from another column in another table, or we can get fancy and start modifying our subquery based off of regular wheres or even wildcard wheres. Any questions there? Okay. I'm going to send you off on the playlist maker so you guys can practice with your inquiries. And then once we get 6 or 7 people who say they are done or ready to move on, we will do that. Give everyone a couple more minutes. If you have got it working, don't forget to update the poll in Zoom just so we know to move on. Otherwise, I will give everyone another minute or two. Got 5 votes in. We'll give you guys one more minute or one more vote, and then I will go over the solution. Okay, we've got 7 votes in. So let's talk through the solution. So first, we just do a basic select. The where we always want to start in a table or in a query is what table are we starting at? So the first step was select the title of all the songs by an artist named Queen. Okay, well, we need to figure out what our table structure is before we can go get the songs. It makes sense that all of our songs are in a table called songs, but if you were looking at the top and looking at the artist table, you'd be like, oh, where are the song names, right? So we want to identify what table we're querying first. So in this case, we say, all right, songs is where it is. Title is the column that we want to grab. And then what was the where condition? The where condition was that the artist was equal to Queen. Now it moves us into the next step, which it's not going to show me, which was basically, okay, now we want to grab all of the artist names. So we go to the artist table, we select the name column where the genre was equal to pop. And because these are quotes, because those are strings stored in the database, SQLite calls them text, we are using quotes around them, and the where query is case sensitive. So when we do our where query, we want to make sure that we are using a capital P there. And then finally, what the last thing was asking was, hey, go get all of the song titles that happen to be in the pop genre. So basically what this in statement is doing is combining the two together. So we're saying, okay, we want to go to songs, we want to pull out the title. What do we want to do? Well, we want to look for the pop artists. So that's how we're kind of tying these two queries together. We're saying, where are the artists? Okay, now artist needs to match up with the name, right? Because the name in the artist table is matching up to the artist in the songs table, if that makes sense. So what we match it up on is the artist and the name, and then we do our additional filtering. So we say still from artists where the genre is pop. So it's important to kind of line up that this is going to match up with this artist here, and then this name here is going to match up with this artist table here, and this artist is going to match up from our songs table, if that makes sense at all. Because artist right here is what matches up is the column name from our songs. And then we are matching name from our artist table to line up with artist from our songs table. It kind of acts like a key. Yes, Carolyn, that's a good way of thinking about it. We didn't explicitly denote it as a key, which we will be getting into a little bit later. But it definitely acts as a key because it's lining up the two tables for us. Any questions on that before we move forward? Okie doke.
Let's continue with more queries of my exercise logs. Let's say that I want to see how many calories I've burned for each type of activity. We can do that with an aggregate query. Say select type and then sum calories from exercise logs, and then we're going to group by type. Now I can see each type with how many calories I've burned total for that type of exercise. Now, do you notice how the column shows up as sum calories in the results? If we want, we can actually tell SQL to give that column a new name just by writing as and then giving it the new name total calories. That can make our results easier to read, and it also has another benefit, which we'll use later. So next, I want to filter the results to only show activities where I burned more than 150 calories total across all the times I've done that exercise. It turns out that 150 calories is the amount in 1 ounce of dark chocolate, so it seems like a good amount to shoot for. Now, my first instinct might be using where to filter. Like if I took this query here and then said where calories greater than 150, then we only see dancing and we don't see biking, which we would expect to see. The reason we only see dancing is because it filters each individual row that comes in. And dancing is the only exercise where I burned more than 150 calories in a single log. But what I want to know is which exercise type or types have I burned more than 150 calories across all of the logs for that exercise type. We actually have to use something new for that, which is the having clause. To use that, we'll remove this where, and then after the group by, we'll write having, and then total calories greater than 150. Ta-da! Now we see biking, because now it's actually looking at the total calories, and I've indeed earned more than 150 over time in my logs. So as you can see, those two queries are actually different, but they are easy to confuse. When we use having, we're applying the conditions to the grouped values, not the individual values in the individual rows.
So quickly jumping in there. So basically what she's trying to say there is the where query is always looking at our data, right? It's always looking at the values in the actual table. But when we use our having, that's when we can hook into anything that we basically have in our select statement and apply those same filtering queries in like we would in a where query to what we are selecting in our data. So you could think of it as kind of a filter before we retrieve our data versus a filter after we retrieve our data, if that helps clarify it.
You could use any aggregate function on a grouped column that makes sense. Sum, min, max, average, whatever we want to check. Let's do another example. So if we want to see the average calories for all the exercises where we burn, let's say more than 50 average total. Oh, that's all of them. So let's up it. 100 in the middle, still doing good. 70, cool. So you can see we can play around with that query there, get different results with that having. Now let me do something a little different. Let's say we want to see all the exercise where we logged at least 2 activities for that type of exercise. For that, we're going to use a count function. So I'll select type from exercise logs, group by type, and then having count star, doesn't matter what column, so we can just do star, greater than or equal to 2. Okay, so now we can see biking, dancing, tree climbing. I've done all of those at least 2 times. Makes sense because those are my 3 favorite activities in life. Besides coding, of course. Okay, so now you've seen having. Remember that it's easy to confuse having with where when using these aggregate functions. So think through your results and make sure they make sense. And now you get to try it yourself.
Okay. I don't think I have anything to add to that, so I am going to send you guys off on the wordiest author challenge. little tip for you guys. If you are getting stuck, you want to make sure you're breaking your queries down as small as possible, right? So first you got to get your select working. And then once you get your select working, you want to get your where working. And then once you get your where working, you probably want to get your group by working, right? So like, just because it's one big query that you're going to be done with doesn't mean you shouldn't be testing in pieces. So as you're writing it, pay attention to what's coming out on that right pane, because that's going to help you break it apart and figure out how to get there. Got 5 votes in. Give you 1 more minute to get us over that 7 threshold, or I will keep going. And don't feel pressured, by the way, to vote or be sped up here. We have a challenge and a project to go in Khan Academy, and then 1 more module after this, and that is it. That is all I'm covering in class tonight. So if you want a little bit more time on the exercises, it's completely fine to set that pace. With that said, we do have 7 votes in. So I'm going to go back to sharing my screen. Okay, so first step here was we wanted to select any author that's written 1 million words. So I'm actually going to delete my solution and talk through how I thought of this. So what I did is I first said, all right, first I need to select my author. So I'm just going to do a select author. And then I'm going to try and break up anytime I issue a SQL keyword command, I'm going to put it in another line to make it a little easier to read. And where am I selecting that from? I'm selecting it from my books. Basic thing, I know I need my author to come out, so I'm just going to get my author to come out. Okay, now looking at all of these results, it's like, whoa, there are a lot of individual rows in here. I would like to group all of those down together. So I'm just going to add my group by and my author. And what that is going to do is, just group by author. That is just going to pull all of my authors down into their 3 individual rows. Okay, great. Now I want to see the total of their words. So if I select my author and I just select words, I'm going to not get the sum of all of their words. I'm only going to get their words from the first row in the database. So I get 197651. Well, you notice that is coming out. I don't even know where that is coming out. It is coming out actually from the last row that it found from J.K. Rowling. I thought it was the first. Maybe that's the SQLite change, but I don't want actually the words from just a row. I want the sum of all of the words. And so what we need to do is we need to come down here and we need to add our sum. And now we're actually getting the total across all of those. Okay, but the sum of the words is kind of not pretty looking, right? So what we can do is add our column alias and just say total words. Okay, now when we look at our table, we actually see a nicer column name coming out there. Okay, all of that is great. But what we wanted to do is filter down so that we're filtering down so we have 1 million words. Well, we could use our where query, but our where query is only going to apply to those individual rows. What we actually want it to apply to is basically the total words column in our select. So because we want to apply that filter to basically our select and not to our data in the database, instead of using our where command, we're going to use having And then we are going to say total words, which is matching our column alias up here, is greater than 1 million. Get enough zeros in there. And that's all it took. We are getting JK Rowling. And it's important to see that because if I comment this out, if I remember how to make a SQL comment, which I believe is 2 dashes, we can see JRR Token and Stephanie Meyer had under 1 million words, right? So feel free to play with your queries here and you know, see different data. If we wanted to see people who had written less than 1 million words, we could easily flip that and see the other 2 authors come out. Brandy, good question. Spreadsheets are often used as an alternative to databases. Spreadsheets don't have the power of relational data, right? So it's harder to tie data from one table into data from another table. So I saw a really great tweet about a month or 2 ago that said, remember, application developers, the biggest competitor to your custom software is always going to be a spreadsheet. And what they meant by that is there is always going to be someone who's got a bunch of data and just needs to be able to work with it. And where is the natural place that they work with it? They're going to pop open Google Sheets or Excel and hack away at it to get it to do what they need it to. So I thought that was a very interesting tweet that I didn't disagree with. So a spreadsheet, you can see, you know, how we could make a spreadsheet that would look just like this. And so when I first learned SQL, I went, this is dumb. I can do all of this in a spreadsheet. Why am I spending an entire year, 2 semesters learning all of this? And then I started learning back-end programming and started realizing that we're using our SQL to get the data out that we need so we can pass it through the back end to get it to the front end. And so now all of a sudden that becomes much harder to interact with. And being able to tie data across, hey, what if I not only want to get all my messages, but I want to get all the messages from this particular user? Well, in a spreadsheet, I would have to have the message content column and maybe the timestamp, and that's no problem storing that. But now if I wanted to store the user's first and last name in a spreadsheet, I would have to add a first name column and a last name column and store their first name and last name across every message they ever sent. And so we are going to get into join queries, I believe, in the next section. Yeah, our next lesson is relational queries, which is how we're going to start tying data across multiple tables together. It's kind of related to subqueries, but we're not quite there yet. So spreadsheets are not based in SQL, but they share common use cases. And so we don't really use spreadsheets in our applications because we use the more powerful databases. But we draw a line between those two because both are ultimately used for storing structured data. So really good question. I'm not quite sure why she used a dollar symbol in the video. Just fast forwarding through to see if I can see where she did that. I'm not seeing the dollar symbol anywhere, Carolyn. So I'm not quite sure.
Oh, okay. I switched to the other monitor because I was having trouble seeing this, and that's what it looked like. It's an S.
Okay.
It's the S's that end the line that drops down.
Gotcha.
Oh God, I need new glasses. Thanks, Max. Sorry.
No problem. And the indentation does not matter. But that is a good question. So you can see, let me go back to my challenge here. You can see I put all of these on separate lines. I think that this makes it a little bit easier to read than if we shoved all of that together. But SQL does not care. So it is just going until it finds the semicolon. And so it is running the next query just based off of where that semicolon is. So it is common to have several queries written out, whether they're selects or inserts or whatever it is, and then to just highlight the one you want to run and hit the run button there. So all we care about is the results of the queries that are coming out, even if that just means the insert, making sure that the data is coming in. So any questions on this?
I was just gonna say, so beautiful code doesn't seem as important in SQL.
Beautiful code is always important because just because we can put it all on one line doesn't mean that we should put it all on one line. JavaScript is pretty much the same way. We can actually take our JavaScript and remove pretty much every line break, put it all on one big line, and the computer will be able to run that fine. There are a couple exceptions in JavaScript, but for the most part, in JavaScript, when we actually ship out our production code, we actually remove all of those line breaks programmatically to make smaller file sizes. And that's called minifying your code. So in SQL, doesn't matter if you put it all in one big line, but if it's a query that you're going to be continuing to work on, it is tradition to have any subquery indented. It is, tradition to follow different line breaks and stuff like that.
Excellent. Thanks, Max.
Okay, so very similar thing here for the second part of this. We just want to change our average to sum. And then we adjust down our threshold because they're only looking for 150,000. And while this would technically work, it's not a good column name, right? Because we were saying total words, where now we actually care about average words. So we're going to update our column name in both our having query and our select query in the column alias to match. And then we have this all finished up. So the next thing to cover is actually an article. If you guys would like to read through this tonight or at some time this week, you are welcome to. But it is basically saying, all right, we're learning all about these SQL queries, but like who actually uses these SQL queries? And so basically they are saying that us as software engineers may want to get data out directly. So we may spin up a connection to the database and run these commands directly, and then pass that through our database. In fact, that is what we will be doing tomorrow. Data scientists will operate with the data directly. They will often save out the resulting queries into what we call a CSV, a comma separated value file, which is basically a universal Excel file. So back in the day, .xls files were the standard for Excel, and it was a proprietary format. So if you wanted to create your own Excel file that wasn't running through a paid version of Excel that you had, there was no way to do it. Office realized that that was pretty stupid in 2007 and switched to the .xlsx file format. And that X at the end stands for XML. So now, if you want to create your own Word file, whether it's a PowerPoint or Excel file or Word or whatever it is, you can actually create your own files using XML as long as you follow the format that Microsoft specifies. So anyway, .csvs are still very common file formats because they're very easy to generate both as us for programmers, and they're pretty universal to read for different spreadsheet programs. So getting data into a database and pulling data out of a database and saving it into a different file, .csv files are still very common. Data scientists obviously work with SQL a lot. What you find is spreadsheets work great for 1,000 rows, for 10,000 rows, not so great for 100,000 rows, definitely not great for 1,000,000 rows. About 2 years ago now, I worked on a project at work where we analyzed health insurance claims to figure out what the most common procedures were, what the cost of the claim was, what actually got paid out, all of that kind of information. Well, this small health insurance plan had about 100,000 insured people on their plan, and 9 million claims over a 3-year period. So you can imagine that taking that data, which ended up being 9 gig of just text, Excel was not going to open that particularly well. And so what I ended up having to do is we got those massive CSV files, imported them into a SQL database, and then started running all of these queries against it to analyze that. So when I pulled that data into JavaScript, JavaScript was like, I don't have enough memory to keep all of that in my RAM. And so we actually had to write our SQL queries on that to get out average information and start doing groupings and stuff like that. Carolyn, CSV files and Excel file formats are separate. Excel can open CSV files, and you can convert XLSX files, which are Excel files, into CSVs and vice versa. Excel file format supports more things. The 2 most common things are text formatting, actually 3. Text formatting, column width, and the ability to have multiple tabs. Those are all 3 things that CSV files do not save in them. CSV files are literally just about saving the data. Excel files can save a lot more into them because XML is a more versatile file format. And we know that kind of because JSON has replaced XML a lot on the internet. And basically whatever you store in XML, you can store in JSON. But whatever you store in an XML file cannot always be backwards filled into a CSV. So if I want to save a chart or, just making sure that when I open that file, it's going to show up the same way the next time, I'm going to need to save it as an Excel file. If all I care about is passing that data around into the next, piece of code using it, I'm going to lean into a CSV because it's much easier to parse the data out of it and to dump data from JSON back into a CSV. But there are very good NPM packages for helping with CSVs and also with Excel files. I'm blanking on the name of the Excel one that I use off of the top of my head. I want to say Excel.js, but I can't say for sure. But my favorite CSV parser and converter is one called Papa Parse, P-A-P-A-P-A-R-S-E, Papa Parse. And they have very fun, entertaining documentation. And their code works great, but their documentation is super easy to read. And so that is my go-to that I reach for, and has over, 1 million weekly downloads or some crazy amount. So that is why I reach for that. But anyway, data scientists will use SQL to analyze their data, especially on large data sets when they can't just run it through Excel. Product management will use SQL to analyze user data, to figure out what parts of their website are being used, to figure out what feature they should work on next, to figure out if there are lots of bugs occurring, maybe we need to prioritize over there. So basically, whenever you have a large data set that gets out of the ability for Excel to be able to retain all of that, that is when you will start seeing people using SQL instead. SQL is often a gateway drug into a full stack developer, because a lot of businesses will say, hey, we've got all of this code here, or all of this data here. We need a way to analyze it. And you can see that the querying and the structuring of the keywords is a little bit more friendly than JavaScript, of diving in there and learning all of those concepts, right? At the end of a day and a half, roughly, of covering all of this, you guys are going to have a base level of SQL, and pretty much all that you will need to know for SQL between now and the end of the boot camp. So a little easier to learn SQL and get into it. With that said, we are writing SQL commands that are, 3-4 lines long. I have seen SQL commands be 4 or 5 pages long. You can start writing really long, complex SQL queries, which we're going to see a little bit in the relational data, but there is a much larger gap between understanding basic SQL and being a SQL query wizard master. And so we are going to draw the line very intentionally at just basic SQL of what we need to know essentially to be dangerous. But if you are interested in doing those deeper dives, I highly recommend those Stanford courses. I believe there are 4 of them, but if you want to skip the unstructured data one, that brings you down to just 3. The unstructured data is going to be more helpful with Mongo and stuff like that, which I will touch on next week a little bit. But if you are really in a groove and really enjoying database querying, feel free to check out those Stanford courses. They are, I believe, 2 weeks each, and they are free to take. And they are in the CIC Student Resources channel. So if you think you will be interested in them at any point, go in there, copy those links, and store it somewhere in your notes before they disappear in Slack. Wouldn't recommend doing those until after the program, by the way, unless you have free time. And if you have free time in the middle of a boot camp, we're probably doing something wrong. But good links and courses I can highly recommend. Okay, on to the next video. Any questions? Okay.
Let's try a few more advanced SQL features. I've been logging heart rate for each of my exercises, and I haven't done anything interesting with this data yet. So now it's time. I did a little research on the internet, and I found that the maximum heart rate is 220 minus your age. So one thing I can do is query my logs to see if my heart rate ever goes above max, since that would be pretty scary, or tell me that there's something wrong with my heart rate checking device. Okay, to do that, I'm going to do a count star. So count star from exercise logs, and then where heart rate greater than 220 minus my age, 30. Woohoo, there's no results, and that makes my heart happy. Now, notice I'm using the subtraction operator, and in fact, I can use most math operators in SQL, like to add, subtract, multiply, or divide. And if I need to, just like in math, I can throw in parentheses and change the order of evaluation. All right, so we've confirmed that my heart doesn't go above max. That's good. Now let's look to see if my heart gets into the target heart rate zone, and that is 50 to 90% of max. So we're going to start with our count star, and we just need to change our where. So this time we're going to say heart rate is greater than, and let's look at 50% of max. So that's 220 minus 30. Okay, so you see I'm combining a few math operators here. And I'm going to also throw in the round function just to show you that we can use that function. It's pretty nifty. And then we're going to say and I'll just copy paste this and change it to less than 90. Let's go ahead and throw a equals in there. All right, so now we're checking to see 59% of max, and we see there are 4 logs that fall in that target zone. But what about my other logs? What zones are they in? We don't know. All we know is that 4 of them are in that target zone. The rest could be maybe they're 90 to 100%, maybe they're less than 50%. What I would really like to see is a summary of all my logs and how many were in each of the heart rate zones. Now that sounds like a situation where I would use a group by, like group by this column that says which heart rate zone this row is in. But I don't actually have a column like that to group by. Well, I can effectively create a column using the case statement. Now I'll admit that I find this the trickiest statement to use in SQL. So I struggle with it a bit, and don't worry if you find it a bit odd as well. It's similar to an if or a switch from programming languages, if you're familiar with those. Otherwise, don't worry about it. All right, so I'm going to use case, but I'm just going to start with outputting what we know, which is type and heart rate from exercise logs, and see what that looks like. Okay. Now for each of these rows, I want to add a new column that says which zone the heart rate is in. To do that, I go into the select part of the query and I'm going to write case to begin the case statement. Then I type when, and the first condition, which is checking if it's above max. So that was heart rate greater than 220 minus 30. Then I write then and an expression, which is just a string. So we'll say above max. Okay, so this is my first case. Now I'm going to keep going with my other conditions. So when heart rate is greater than 90, then we'll say it's above target. And then, so greater than 90, and then we'll say at that point, if it's greater than 50, we can say it's within target. And everything else would be below target. So I could do another condition for that, but I can also just be lazy or smart, however you want to think of it, and say else below target. Okay, now my conditions are all done, but I haven't told SQL what to name this new column. For that, I write end as HR zone. Awesome. So now for each of the rows, I can see the new column with a nice description of what zone they're in. Now that we've done that, finally, I can make a query that summarizes how many of my logs are in each of the zones. And that is a whole lot easier now that I've set up this case. I'm just going to take this query here, copy it, and I'm going to group by the new column we created, and then add count star, get rid of the heart rate, see what we have here. Aha! And now we see that we've got 4 below target and 4 within target. That's pretty neat, huh? That case statement, it is a tricky one, but it sure is handy once you get the hang of it. You may not use it all the time, but it's good to know just in case.
All right, first off, props to the pun, just in case. But this, I can tell you honestly, I learned this 10 years ago and completely forgot that this was even a thing in SQL. It is definitely helpful. You can see in the output when it's going to be most useful to be able to actually write an if statement right into your SQL. But when we actually use SQL as a full stack developer, it would be much more likely that we would pull the data back into our JavaScript and then manipulate the data in our JavaScript before we send it back. So it would be much more likely that we would be writing this as an if statement in our JavaScript code, as opposed to writing a more complex SQL query for this. But important to know, and if you're working only in raw SQL and need to be able to pull off something like this, nothing wrong with using the case statement. So we are at 7 o'clock now. So I'm going to say let's take a break until 7:20. When you get back, I will go over the gradebook challenge with you. And then I am going to skip into the relational queries and save the project for you guys for homework. So if you get stuck on that, you have any questions, I can either answer them at the end of class tonight, or you can submit whatever you have and I will provide feedback in, I'm guessing, Google Classroom. I don't think there's a way for me to provide feedback in Khan Academy itself, but I will figure that out. If you, so I would work on the gradebook challenge. We will circle back at 7:20, go over the gradebook. Feel free to work on the project because that will be homework. And then we will move on to relational queries and skip over the project when we get back at 7:20. Any questions? Screenshots cannot be uploaded to Khan Academy. They will be able to be uploaded to Google Classroom. But I wouldn't worry too much if you can't get something to say that it is complete. Don't worry too much. You're not, if I see that you have gotten, 15 out of the 17 assignments done, I'm still going to give you guys full credit for attempting them, even if you got them done and Khan Academy was just being a pain, which free code camp struggles with as well. So I'm not quite sure what's so hard about that. But anyway, all right, take a break. I will see you guys at 7:20. We'll go over a grade book. We're going to skip over the project, save that for homework for you guys, and move on into the next module and the final module. All right, I'll see you guys. And if anyone has questions, feel free. I'll stick around and answer whatever you've got, except Latonia, because I'm going to go over it with you when everyone gets back. I am back if anyone has questions between now and the next 15 minutes. I'd say 7:20 or 7:25, we would be back. Okay, I said 7:20. Yeah, I think I did 7:20 because we breaked at 7. Okay. Okie doke. Let me share my screen. We can talk through the final exercise, and then I will save the project for you guys to do for homework. So what they wanted us to do here was they have our grades in here, and before we write any query, we always want to look at the table structure first, right? So our table is called student grades. We've got an ID like we always do, or we should always do. And then we've got our name, which is coming in as text, the number grade, and then the fraction completed. And so what we want to do is select all the rows, display the name, number grade, and percent completed, which you can compute by multiplying and rounding the fraction completed. So we need to basically multiply fraction completed here and then round that off. So we are going to come down here and we're going to just start with our select star from student grades and make sure we get our query coming back. We do, we can see our data. And so now we can come in here and say, well, we wanted the name and the number grade columns. And then we wanted to take our fraction completed column and multiply it by 100, which is going to give us our number. But there are some nasty decimals there. So what we are going to do is just drop in our round. And add in our as and give it a nice name like percentage spelled correctly completed. Complete. Did I do a typo? Percent complete, not percentage complete. Okay, that finishes that one off. It will round up, Carolyn, if it's above, if it's 0.5 or above, and then it will round down if it is 0.5, if it is below 0.5, if that makes sense. It rounds to the nearest whole number. That's what I was trying to say.
How did you know to use 100? That's what I couldn't figure out how to do the math. I didn't know what I was supposed to be doing.
Yeah, so if you look, the decimal values are all between 0 or 1. So we're basically converting it from a decimal value into a percent value. So like if the grade was, if we're looking at 90 point, or if we're looking at 0.906, that is 90.6%. So we just multiply by 100 to move the decimal over 2 places and then round to bump up that decimal either up or down. If that makes sense.
Yeah, I just would never figure that out.
Yeah, sometimes the answer is in the data itself. And so they call the column fraction completed, which is not going to help you get to figuring out that multiply by 100. But then looking at the data itself, I'm looking at this and I'm going, oh, all of these are between 0 and 1. And oh, it makes sense that, you know, this person has a 50% and this person has a 90%. So I just need to move that decimal place over in order to display it as a whole number. And that's a very common thing in JavaScript and SQL and whatever, converting from fractions to decimals and back and forth.
Okay, because it also said real and I didn't know what that meant either.
Real here means double or float, meaning that it can take a decimal number.
Oh, okay. So it's still an integer. It's just
integers tend to only be whole numbers. They don't take decimals.
Okay.
So real is the data type you use in SQLite to be able to store a number. But every database has a different name for a number that can take a decimal. So double, real, or float, or 3 common, or decimal itself are the 4 common data types that all mean that number can store a decimal.
Okay.
Good question, though. Thank you for asking.
Sure.
Okay, any other questions on that before we move on to step 2 here? So now we want to basically do the same thing, except we want to figure out a letter grade with it. So I'm going to start with my select statement, and I'm just going to do the count here because all we care about is the count of each letter grade that we get. And we are going to do it from our student grades. And what we want to do is get our letter grade working. So basically, they get an A if it is above a 90, B if it's above an 80, and C if it's above that. So I'm going to add another column here, and I'm basically going to do my case. And then I'm going to say when the number grade column is above a 90, then the column of our output value is going to be an A. And then when the number grade is greater than 80, then the column value is going to be a B. And finally, when our number grade is greater than 70, then our column value is going to be C. Else, it is going to be an F. And then whenever we do our case, we need to end our case as well. And that obviously is very, very messy there. So we are going to alias that as our letter grade, which is going to make it show up here a little better. But now we've got 6B letter grades, and it's like, oh, that's not what we want. What we really want to do is group our letter grades together, because otherwise it is just counting all of the letter grades as opposed to counting each individual letter grade. And so all I need to do is come down here and add my group by and add in my letter grade. And that is going to give me my A, B, C, F and the number of students that got each one of those grades. Do I see enough minds being blown to move on to the next lesson, or do we have any questions?
So count just creates a counter, basically. It starts with 1.
Correct.
Okay.
Yeah, so if you look at our grades up here, you can see how many people there are. 3 people that have a C because they're between 70 and an 80. And so it's literally just counting the number of students there are and then adding that up. I'm sorry, there are 3 that have a B because they're between 80 and 90.
So when you just type select count and then with the star in the parentheses there, by itself, it just says 1. So is that selecting something particular, or is that just starting with 1 because that's how it initializes?
Sorry, ask that question again.
Is that selecting something particular, like the first grade or something like that? Or is that just, it starts with 1 because that's how a counter starts, like starts with 1?
It's counting the number of rows by that come out of the group by. So because there's 1 student with an A, there's only 1 row there. And so that's why it's showing that.
No, I understand that, but if you just have select count, if you haven't typed the case and all that.
Yeah, it's going to, I may have to remove my group by as well. It is going to,
It just says 1 on mine when I did that.
should be 6.
Hmm.
Because there are 6 rows. And so it should be counting all the rows.
Okay, I don't know why mine's not doing that, but
There no changes in the insert statements above, are there?
no, I don't think so, unless I did something accidentally that I didn't.
If you want, you can copy out the select statement that we did for the first part and then hit the start over button. And that's going to like reset not only your text over on the left, but anything that's over in the database. And then you can try this code again and see if that just, something happened in the data.
Okay.
The other thing you could do is just select star from student grades and see what is in the database, just to debug why your count was coming out as 1. And by the way, if you see those dashes, that is like a // in JavaScript. That's how we do a single line comment in SQL. And make sure you've got a semicolon at the end because it will yell about syntax statements otherwise. Okay. Any questions? Okie doke, on to the next module. Yeah, you can do multi-line comments with /*. -- are just single line comments. So whatever works is fine. Okay. So this is, I will try and talk through this article as much as possible. So we want to start talking about our data modeling, right? And there is, while we talk about dry principles all the time of don't repeat yourself in in programming all the time, it is even more important in the database. And so if we think about our messages app, right? I will stop sharing my screen for 1 second. Okay, so if we think about our messages app, we could have our app and put, like I said before, our message content, a timestamp column in, and a first and a last name. Okay, but what happens when the user goes, oh, I would like to update my name, I just got married, or, for whatever reason, I want to go change the name that's being displayed. Well, we would like to update that in one place and have it just magically update everywhere. Well, if we had it in the first name and the last name column on every message they sent, now instead of being able to update one row, we would have to go in and update every time they have sent a message. Okay, well, what happens if we now also want to keep track of our chat rooms? Well, we could go create our chat rooms table and say, hey, the person in room 1, their name is this. And oh, and in room 2, they're also there. Well, now not only are we storing the name in the messages table, but we're also storing it in the rooms they are in table. Well, we may look in our database, see that, the name is on the message, go update it there, but forget to update it in the room they are in message. So, or in the rooms they are in table. So now when they're interacting and sending messages, their name is showing updated and correct. But when they go in and they click to see what rooms they are a part of, their name may be showing up incorrectly there. So what we want to do is have our one users table, and that user is going to store the first name and the last name, and that user is going to get an ID. We are going to use that ID, which happens to be the primary key, the primary way of identifying them in the users table, and use that primary key as part of a foreign key in the messages table. So now in the messages table, we are going to still store the message content. We're still going to store the timestamp because those are unique to the message. But instead of storing first name and last name, we are just going to store the user ID, which is going to be a foreign key. And it is foreign because it matches up to the primary key on the users table. Now, you may say, Max, that makes total sense, but I'm having a hard time visualizing that. Then hold on to your hats, because next week we are going to be talking about entity relationship diagrams, or ERDs, which are a standardized way of creating your database schema, basically laying out all of your tables and showing how they relate to each other. So we will be going over ERDs, and I am hoping to find another video of someone who can explain them much better than I can. So we will be going over that next week and practicing a little bit of creating our ERD for the messages app. Normally you create your ERD before you create your tables, but I don't want to have you guys in a vacuum of the database for too long. So tomorrow we are going to dive into getting our databases set up on the computer, getting it working in our messages app, kind of seeing a real world example of the database. And then next week we will go back to more concepts, and then we'll flip back in and get that practice. So trying to not dump all the concepts on you in week 1 and then be like, oh, by the way, let's go use all those concepts. I'm trying to interlace that content a little bit. So we are not all in concepts. Let me just make sure I didn't miss anything. Yeah, so if you want to read that splitting data into related tables, they go through it using books, and they use something called a join table. That is basically saying, well, we've got a bunch of books and we've got a bunch of borrowers. So what happens if we want to keep track of what books each borrower has? Well, we don't want to put that all in a books out table, because then if we are keeping track of the user ID and the book title and the author and all of that, every time a book gets checked out, we aren't duplicating the user data, which is good because we're using the user ID, but we're duplicating the book title and the author and all the other information with it. So that is when we are going to use a special kind of data table that is literally, we've got our users and we've got our books, and then our books out table is just going to have two columns. It is just going to have our user ID and our book ID, and from that we can relate that data together. Now you may be saying, okay, that all makes sense. I understand the table structure, but what happens when we want to just say, hey, show me all the books this user has out? Well, we haven't really gone over how do we query from like two tables. How can we select some columns from one table and some other columns from the other and use that to get a query that starts to make more sense to us? Because storing the data in the database, deduping it and making sure we're not storing multiple things makes sense from a data structured side, but it doesn't really make sense from our side of, we would like to just see all the book titles the person has out. So that is what we are going to dive into now. Any questions before I kick off the video? Yes, Carolyn, entity relationship diagrams are akin to our wireframes. It is basically how we plan out a database before we start coding it out in SQL or in JavaScript using the ORM. Okie doke, off we go.
I've set up two tables in this database. A students table with detailed information about each student, like their name and email, and a student grades table, which has their student ID, test name, and grade. Let's see what happens if we just select everything from student grades. Ta-da! Okay, so we see student IDs, test names, and grades. I'd actually rather be able to see student names, emails, that sort of thing. Now, what you might notice is that the student ID in student grades is related to the ID in students. So this 1 here is actually referring to Peter Rabbit, and this 2 here is actually referring to Alice in Wonderland. Now, I want to form a query that will output the student name and email next to each test grade, and that information is in 2 different tables. So that means I need to join the tables. And there are a few ways that we can do that in SQL, and we'll try them all out actually. The simplest is called a cross join. And I can make that happen just by putting both table names after the from. Ta-ta! So as you can see, lots of rows. And basically what this did is that for each row in the first table, it created a row for each of these rows here. That means we end up with 8 rows because it creates 4 rows for each of these 2 rows. This is the simplest join, but it's also the least useful. We don't want every row matched with every other row. We only want them matched if the student ID matches. Now we can do that using an inner join, which isn't actually much more work at all and is way more useful. So there's actually a few ways of doing an inner join. We'll start with just building off the last query, and we can add a where. And the where will check to see that the student ID matches student's ID. All right, so now we actually have what we wanted, is test grades next to names, because it's done the cross join and then just limited to the rows where those columns were the same. Great. This syntax here is called an implicit inner join, and it works, but it's not actually the best practice. The better way is if we do something called an explicit inner join. And that is using the join keyword. So to do that, we're going to start with just doing from one table. And actually, I'll do from students, and then join on student grades. And then instead of where, we do on. And that specifies what columns are being matched. So on students.id equals students grade dot student ID. All right.
So just to jump in there, we can't just say ID or student ID here because it's like from what table, what columns am I looking at, right? So we have to add in the whatever the table name is dot and then whatever the column name is, because students actually has an ID column and student grades also has an ID column. So it's like, what ID are you talking about here? And so that's why we have to get careful and say what table name we want it from. I'm sure they're probably going to get to this, but we use that same technique in the select as well. That select star, you can see right now it is pulling in all the columns across both the tables. But if we wanted some columns from one table and some columns from the other one, we would use that same dot syntax to specify what columns from what tables we wanted.
So now we have the same results as before. Switched, but really the same. Now that I have these tables joined, I'm just going to whittle down the columns I'm outputting to the names, the email, the test name, and the grade. Okay, beautiful. Now, the cool thing is, once we've done joins, we can still use where and group.
Sorry, jumping back in there. We do not need to use the table name dot when the column name is unique. And so if there is no overlap between the columns in the first table and the second table, SQL is smart enough to go, all right, I'm looking at these two different tables. There's only one first name, so I don't need to specify what table first name is in, because there's only one of them.
By and all those fancy things. Like, let's say that we want to filter down the results to just grades greater than 90. Woohoo! Let's see. Oh, no. Grade. There we go. Haha. Lots of ones above 90. Now I can email all those students with a high five. Okay, but what would happen if my tables both contain columns with the same column name but different meanings? Like right now, our student grades table has a grade column. Well, what if my students table also had a grade column for their overall class grade? That would mean down here, when we selected grade, it wouldn't know which table to pull it from because there'd be a grade column in both of our tables. So actually, to be super safe, we should prefix our columns with the table name that they're from. So we say students.firstname, students.lastname, students.email, studentgrades.test, studentgrades.grade. Okay, now we know that we're going to get the columns from the table we expect them to be in. Great. Now that is our basic explicit inner join, and it is what you'll use for most of your joins across related tables. But if you stay tuned, I'll show you a few other types of joins as well.
Okay, so joins, really the fundamentals of a relational database. It is the way that we can not duplicate our data. Super common to be using joins. We will be covering how we do joins in the object relational database as well, and actually telling our code, hey, these two are related. So when I ask for this, you should just do the join automatically for us. The reason why the explicit join is the best practice, Shahil, that's a good question. It is how the database is executing the query under the hood. So basically, when we do our from and our where, it is running two separate steps. It is pulling both of the tables in. And then once it has both of the tables, only then, once it has all of that data loaded up, is it trying to match the data together. When we do an explicit inner join, the way it works under the hood is it says, let me get the first table. And once I get the first table, I will only try and match the things into the second table without having to have both of those tables preloaded to match them together. So some databases over time have realized that implicit joins are easier to write as a developer. And so they have started to optimize that code to actually do an explicit join, even when you write it as an implicit join. But that is getting under the hood of kind of figuring out how the databases work and store data and execute the queries and all of that stuff. There is so much voodoo under the hood to make it so I can run a query on a 9 million row database and just get the average of all of the numbers across those 9 million rows in like a couple seconds. If I try and do that in JavaScript just blows up. Flames start coming out of your computer and it's like, can't process 9 million rows. But because databases are so well optimized, that as long as we are storing the data properly and not duplicating the data and specifying the correct column types and all of that stuff, there are some crazy optimizations that the database is able to do. And so that is why we use an explicit join, or it's better to use an explicit join because the database isn't trying to load both tables. It is only loading one table up, in this case, the students table. And then it is matching it on the student grades and only pulling the part of the student grades that it needs to match things up. It's not quite asynchronous. I wouldn't quite think of it that way, Jahil. It is more just only loading in the pieces of the data it needs and processing the matching on the pieces that it needs to match, instead of loading both tables and then trying to match it after it has loaded both of them. I don't really want to breach the topic of asynchronous in the database, because there is the notion of transactions in the database, where you can basically say, run this group of queries, and if anything fails in those queries, roll back to what happened before we ran those queries, and then only keep the result of those queries if all of them run successfully. Transactions are a little bit more advanced than what I want to get into in the database. If I am out of topics to cover next week, I will be diving into that. But I think I would rather cover more hands-on full stack examples than go too far down into transactions. But with that said, we will, when we get over to our node code and executing our queries, every database query we run is asynchronous. We may want to run a database query, go do some other JavaScript code, and then wait for that query to finish running before we run more database code. So we will be using async and await when we get over into our node code. But I wouldn't go too far down that rabbit hole of why implicit versus explicit. Both of them are kind of acceptable. It's just easier on the database to do an explicit return because it knows exactly what it should be matching on. But like I said, most databases today have done those optimizations. So even though you are doing an implicit one, it is using all the optimizations that the explicit join uses. Did that answer your question? It does save processing power. Yes, the explicit join would save processing power over the implicit. And not just processing power, but also data loading as well, right? It takes processing power to go run your query. It takes memory retrieval power to pull that out of the hard drive. And then it takes more processing power to match up the data that it has to your implicit join. And so you're saving not only time running the initial query, but also on the data retrieval and then also on the data processing. And that is pretty much where I draw my line of there's Voodoo that works in the database and I just know how to query it. I do not get too far into all the optimizations that happen on each of those queries. But if you are interested in that, Postgres, I believe SQLite and MySQL, all open source projects. And there are a ton of YouTube videos that you can watch of like, how does MySQL work? And there is some nerd, and yes, I use that term because I identify as one, but a even bigger nerd than me to dive into how the database works behind the scenes. It is not a topic I would encourage you to go too far down, because I personally, in 10, 15 years of professional development experience, have never needed to get to that level of database optimization where like I need to know how it works behind the scenes. But if you are interested in it, I cannot stop you from digging more into that. And I believe the Stanford courses will probably go a little bit into that as well. Okay. I'm going to stop my screen share. I'm going to let you all try the Bobby's Hobbies challenge. And then we will go over that once the poll has a couple votes in it. If you have any questions as you're working through them, feel free to shout them out. Just to show you how prepared of a teacher I am completing the assignments as you guys are. So I just got through it myself. I mean, I did these months ago and know these like the back of my hand. So there are two people that have gotten hung up on this. So I'm just going to throw it out there. There is no person ID in the persons table. There is an ID in the persons table, though. And so what we are trying to match on is we are trying to match up the person who has an ID in the persons table to the person ID in the hobbies table. So we don't care about the ID of the hobby. We care that the person ID in the hobbies table is matching to the ID in the person table. Let me draw that in case that helps visualize it for anyone. So if we look at our schema, we've got our person ID in the hobbies table, but we want to match that to the ID in the persons table. And so what that looks like is we are matching this person ID in the hobbies table to this ID in the persons table. And so when we do our inner join, we want to make sure we're saying persons.id is equal to hobbies.personid. And if you're still stuck on that, I can go through that when I talk through my code. Yes, Carolyn, persons can have more than one hobby. So that is what we would call a one-to-many relationship, and why we have to split these into two different tables, because otherwise we would be duplicating data. So while web standards have changed a lot in the past 50 years, databases have not. SQL is still pretty much the same as it has been. There are newer versions of SQL, but the core fundamentals of the database have not changed since the 70s, which is why when I learned the database 10 years ago, it is the only college textbook that I have that still is relevant, because every other coding textbook I have has been replaced by a newer language or a newer way of doing it, but the database is good old faithful and has not changed much in the past year. So I'm going to give everyone until 8:05 to get this one done. I'm going to talk through the code for this, of how I got it working, and then we are going to change gears. I'm going to override Caitlin's tie-breaking vote, and we are going to play through the rest of the videos, just so I make sure I get through all of those by 8:30. And then I will leave whatever time is left to help on the challenges, if that makes sense. But we'll give you guys 2 more minutes on this one before I explain through it. Susan, I am not ignoring your question. I'm just thinking about it. Order does matter for things like in your select statement. If you would like your columns to come out in a different order, it will always respect that order. For an inner join, I do not believe order matters. So it doesn't matter if you select the hobbies first and join it to the person or vice versa. I want to say for other kinds of joins, it is going to matter more. I can't think of them off the top of my head, though. But I'm guessing that you have a different issue than the order. So I'm going to talk through my code now. And if you still can't figure it out, I'll let you screen share after I talk through mine. Okay. So I have cleared mine out. Okay, so step 1, we need to add a new person into our persons table. So what I am going to do is I'm going to insert into persons my name and age, and they are going to have the values of Testy McTesterson, and they're going to have a negative age because I feel like it. And I don't really know if that's worked or not. I'm not getting any errors, but I need to know the person's ID in order to be able to start using them in my hobbies table. So what I'm going to do is I'm just going to throw a quick select star from persons, and I'm going to be able to see that I forgot a quote. There we go. And now here's my query, and Testy McTesterson is in, and Testy McTesterson has an ID of 6. So because I have that ID of 6, now I'm able to use that in the second half of this assignment. So I'm going to comment out my select from persons, and I'm going to come down here. I'm going to copy my insert into hobbies, and I'm going to use an ID of 6. And the hobby is going to be DB Mastery. And I'm going to do the same thing down here. I'm going to select star from hobbies and just take a quick look of my person ID 6 has DB Mastery showing up here. Okay, great. So I'm going to comment that out, move on to the next step. Select the 2 tables with a join so that you can see each person's name next to their hobby. Well, sure, I can do that. I can do a select, and I'll select everything from both my hobbies table and my persons table. Okay, well, here's all this data, and there's a lot coming out over there. So I'm going to whittle that down. I'm going to say I would just like the persons.name and their hobbies name. Okay, well, I selected two tables, hobbies and person, and I can see their name and their hobby. Okay, so I was lazy and I did an implicit join there. I should probably do an explicit join there, which is going to let me move on to the next step. So I'm going to comment that out, and I am instead going to say select my person's.name and my hobby's name as well from just the hobbies table. But then I am going to join my persons on the person's ID, matching up the person's ID from the hobbies table. And I'm going to refactor my code to be a little cleaner whenever we use a SQL keyword. I'm going to put those on separate lines, and I've got that done. And then finally, it would like me to use a where command as well. So I'm just going to grab that, come down here, and throw a where. And then I am going to say where the person's name is equal to Bobby Bobby. Susan, did you find why it wasn't running? Okay. Any questions? I know we're getting towards the end of the night, so I am just going to play through the videos, and then the rest of this will be homework for you guys. Sound good? You all thought I was going slow last night. Now you guys are like, SQL overload. All right, let's keep going here.
I'm back with my related tables about students, with the students and the student grades. And I added a new table to keep track of what projects students are working on. And once again, this one has a student ID to relate it to the students table, just like the student's grade had. And it also has a title for each project. Now what I want is a list of student names and the projects they're working on. So that means I need to join student projects with students. We can do that, as you probably guessed, using an inner join that we just learned. So what do we want? So we want students.first name. We want students.last name. We want the title of the project, so from the students projects table. And then we'll say from students, join student projects, and on students.id equals student projects.student ID. All right, so I see one project, Peter, and his very promising Caratapult experiment. But where is my other student, Alice? Well, we're missing Alice because an inner join only creates rows if there are matching records in the two tables. There's no row for Alice because there's no row in student projects that has Alice's student ID in it. And this makes sense, and oftentimes with joins, we do only want rows where the records matched. But in this case, we want a comprehensive list of every student and their project, and we want every student to be on that list, even if they don't have a project yet. And that is where an outer join is super useful. And it's really easy to use. We're just going to go right here and type left outer. Ta-da! Now we see Alice, and there's a big old null for the project title. Okay, so how this works is that the left tells SQL that it should make sure to retain every row from the left table, which is the one after the from, students. And the outer tells it that it should retain the rows even if there's no match in the right table, which is student projects. And that's our outer join. And there's a lot of cases where you might find you want an outer join, and just keep in mind that the behavior of inner versus outer joins. There are also some other sort of outer joins. There's a right outer join, and it basically does the opposite, is make sure that it keeps everything from the right and then joins with the left. We don't actually support right outer joins here, but if you want that, you can just switch the table order and it's the same thing. So you don't actually need to have a right outer join. You can always use left outer join. And there's also something called a full outer join, and that matches rows, if it can, on both the left and the right side, and fills in nulls when it can't on either side. And that's pretty interesting, but also is not supported in our environment here. And that is one of the interesting things about learning SQL. I'm showing you lots of things that work here and work in other SQL environments, but every environment is a little different. So you'll constantly be tweaking the tools in your SQL toolbox for each new environment. And that's true about a lot of things with computers, honestly. You'll learn the general techniques and then learn how to adapt it for a specific language or app or environment. And you basically just get really good at learning. So yay!
So we use our inner joins probably the most, the join type that we first learned. It's pretty rare for me to need to do a left join or a right join. And then the full join is basically where we are selecting both tables and then just matching things up. So we basically don't do a where, we just do a from and a comma and then list our two tables out. So I posted a link to a diagram. We are literally just using Venn diagrams here, right? So we've got table 1 and we've got table 2. And then based off of what kind of join we are doing, we are controlling whether we get access to what overlaps in the center or what overlaps in the center and the left table, or what overlaps in the center and the right table as well. And so that's when we get our left join and our right join, because it's saying, okay, what do we want to overlap there? So different join types. You'll go through that on the exercises for the homework tonight, but I'm going to steamroll forward if everyone's all right, unless anyone has a question. Okie doke.
I'm back with just the table about students this time. I've added one more column to the table, buddy ID. See, I decided that every student should have a buddy, somebody that they can pair up with, do assignments with, study with, all of that. Now, the buddy ID is what it sounds like. It's an ID that relates to the ID of the student that they're buddied up with. So, for example, here, Peter is buddied up with 2, and 2 is Alice. Let me just do a select that should make that more clear. So select the ID, first name, last name, buddy ID from students. Okay. The interesting thing here is that this buddy ID is a column in a table that's related to another column in the same table. That's a bit different from before, where we'd have columns related across different tables. So, what if we wanted to show the names of each student next to the email of the buddy? Not just the ID, the email. To do that, we need to actually join the students table with itself, because the two bits of related data that we need both happen to be in the same table. We can do that by, let's see, so we want the first name, last name, email. So to join students with itself, we're going to write from students and then join students. Okay. All right. Okay, so we get an error. First name is an ambiguous column. And that's true. We're telling to select first name, but it's joining across two tables, and both of these tables have the same column names. And before, we would just prefix these with the table names, but we can't do that here because actually they're both named students. So we need to give it a way to distinguish between this one and this one, even if they're kind of the same thing. And we can do that by giving one of them an alias. So we're going to write the alias right after here. The alias is like a nickname. So here's the alias, buddies. And then we just have to specify that the email is coming from buddies.email. Haha. There we go. Now we're seeing too many rows, way too many rows, and that's because we don't have an on clause yet. So it's just joining every possible row with every other one. Now our on should check that the buddy ID from the students table, that first one, matches the ID from the second table, buddies, or what we called buddies. Haha! Now we can see Peter with Alice's email address, Alice with Peter's, etc., etc. To make this results table even a little more clear, I'm going to rename Buddy's email as Buddy email. Okay, so now it's a lot more clear that we're looking at Peter Rabbit and his buddy's email. Cool. Now this type of join is called a self-join, and that's because it's a table being joined to itself. You can try this out in the next challenge, and I'll show you one more way to use self-joins in the talk through after. I hope you'll join me. If not, just join yourself.
Any questions? I've got nothing to add there other than pun appreciation. Okie
I
doke.
think you've been punned out, Max.
We've got one more video to watch, and then there is a article on more efficient SQL. I did not assign that, but if you would like to read that, I would tell you guys to go for it. It's probably a good article to read.
Now I want to show you a combination of joins and self-joins. So this time I'm back with multiple tables, tracking the students and their projects. Now, since I have students working on great projects, I want them to review each other's work in pairs. For example, hyena habitats should review carpet physics. That's why I've created this new table, project pairs, and all it stores is 2 project IDs that are paired with each other. Now, let's see. What do I see if I select star from project pairs? Ugh, okay, it's just a bunch of numbers, a bunch of IDs, all the IDs that are mapped with each other. It is not the most human readable output at all. What I'd like instead is rows of project titles paired with each other. The project titles are in the student projects table. So that gives me a clue that I need to somehow join project pairs with student projects. Let's see what happens if I do that. Aha! So now we see project IDs and project titles in each row. What I eventually want in the results table is to see 2 project titles in each row, not just one. So that's another clue that we need to do another join, a self-join of student projects with itself, so that we can get those same column values twice. Now, it may not be obvious how to add a self-join at this point, because we already have a join. If we want to add another one, we can actually use the join keyword again. So join student projects, and we need to make sure we give them different aliases so that they're not ambiguous. So A and B. All right, so now we've got a lot of stuff in this results table, but if you'll scroll, you'll see that the project titles show up twice in each row. So maybe let's make it easier to see. A.title, B.title, great. But we still have way too many rows because we're matching every row with every other row, and we haven't added the on clause, the very important on clause. So we're actually going to add 2 on clauses, one for each of the joins. So on project pairs, that's project 1 ID equals A.ID. And then on project pairs dot project 2 ID equals b dot ID. Aha, there we go. So thanks to this combination of joins and self-joins, we can see a nice list of project titles paired with their project title. Now you can use as many joins in your query as you need to get the data that you want, but generally more joins means slower queries. If you're interested in how to figure out if your queries are slow and making them more efficient, we'll talk about that soon. So stay tuned, keep at it.
No fun pun at the end of that video. What I did realize is that there is one more, they call them lesson, basically one more group called modifying databases with SQL that goes through update and delete commands. We have seen selects, we have seen from, we have seen inner joins, we have seen on, we've seen where, we have seen having. The last probably two most important commands are update and delete. And I completely forgot that that was another lesson. So we will start there tomorrow and chug through them very quickly and then jump ship out of a Khan Academy and get into getting our databases set up locally and getting our node code connected in to be able to run all of that. I will go over modifying databases tomorrow. Tonight for homework, if you want to catch up on the exercises we leapfrogged over, feel free to do that. They aren't due until or not due until Sunday at midnight anyway, 11:59. But we've got one tiny little bit left to go in Khan Academy, and then we will be fully wrapped up. 6 minutes for any questions that you have, or any complaints about how there's too much in your head and it is now spilling out of your ears. Okay, I'm going to throw the classroom feedback form in chat unless Caitlin beats me to it. There is one. There is. I'm just going to leave it in the Zoom chat so I don't clutter up the clutter up the Slack channel. Latonia, thank you for the reminder. Office hours will be Friday at 7:30. They will be recorded. They will be live streamed on YouTube. As always, you are welcome to send me questions if you are not able to make them, and I will answer them in office hours. No major changes there. You can tell how tired I am by the end of the night because I just keep on shrinking further and further down. Just terrible posture. Okay, there we go. Back, I'm up. I will stick around for the next 4 minutes if anyone has questions. Otherwise, go fill out the 30-second feedback form and get out of here. I'm going to jump out unless anyone has questions.